All right, lesson 6.2, video 2 on trapezoids. Let's jump right in. All right, here we go. It says, Keo is designing a trapezoid-shaped roof. In order for the roof to be symmetric, the overlapping triangles, triangle DAB and triangle ADC, must be congruent. Will the roof be symmetric? So basically what we're trying to do is, can we prove that triangle DAB is congruent to triangle ADC? That's what we're trying to do, right? So if we take a look here, we're given something. We're given that segment AB and segment DC are congruent. So that's one thing that's going to be helpful. So segment AB is congruent to segment DC. All right. So we're going to learn later that this means that this is called an isosceles trapezoid. Isosceles trapezoid. It's a trapezoid with two congruent sides. But that's future information. Okay. Now we have to know the definition of a trapezoid. By definition, okay, a trapezoid has one pair. A trap has one pair of parallel sides. So in this picture, those would be B, C, and AD. Typically, we call those the bases of the trapezoid. So that's a little bit of background knowledge. Okay? All right, so how are we going to see if triangle DAB is congruent to triangle ADC? Well, we're going to do like a little mini proof. Okay? So first, okay, we are given that segment AB is congruent to segment DC. Right? That was given to us. So we have a pair of sides, right? Sides. Okay. Now, this is kind of where, like, you know, the math teacher is going to step in. We're going to draw some altitudes. Remember, altitudes from lesson, I think 5.3, altitudes are perpendicular. And in terms of your trapezoid, it's going to be from one base to the other. So we're going to draw altitudes BE and CF. So BE is going to start at B and go down. Call that F. CF is going to start at, I'm sorry, this is BE. I apologize. And then CF is going to go down. Right? Okay. So here we have some right angles now because they are altitudes. Okay. So we're good there. All right. So, and we can just draw this because we can. Okay. So now, so because of this, we know that BE is congruent to CF. And again, it's the idea that because these lines are parallel, the distance between them is going to stay the same. So it's because the parallel lines we say are equidistant. Sorry, equidistant. I'm not spelling very good or whatever. So these two sides are the same. Now, those two sides are not in our overlapping triangles, but we'll see what it can do to help us with our proof. Okay, and now because of this also, I'm going to do the same step. We also know that angles AEB and angle DFC are right angles. And again, that's because we drew these altitudes. So then, just long story short, right, that means that these two triangles are right triangles. We have a pair of sides, which are the hypotenuses. We have a pair of sides, which are the legs, and we have the right angles, which are right triangles. So therefore, triangle AEB is going to be congruent to triangle DFC by HL. Anyway, so well, how does that help us? That's not the two triangles we're going to focus on, right? We want to focus on, you know, the overlapping triangles, right? I'll do one. I want to focus on ABD. Well, in ABD, we can also use side AB as a side, right? There is a pair of corresponding parts of these right triangles that is also an angle in the big purple triangle. And that's this angle here at A. right? So because these two triangles are congruent, in step 4, which I'll do here, hopefully you have some room, in step 4, we can say that angle BAD is congruent, BAD is congruent to CDA, and that's by CPCTC. Now notice I did do BAD, I probably should do BAE and CDF, but I just extended it all the way out to the side for the new triangle, right? Okay, so now that's a pair of angles. So we have a pair of sides, we have a pair of angles. Where is the last thing going to come from? Well, the two triangles overlap. I'm going to do this one in yellow just so you can see a little bit better. They overlap on this bottom side. This bottom side, I'll use 3 dashes, is congruent to itself. Ooh, can't do that. So step 5 here. So we know that segment AD is congruent to itself. And that's by the reflexive property, because it's used in both triangles. And now that is our second pair of sides. We have side, angle, side. We now know that triangle DAB is congruent to triangle ADC by side, angle, side. And because we're able to prove those two triangles congruent, this roof is symmetric. And we're good. So talk about a great first problem for a video, right? But here you go. Very interesting. All right. Using overlapping triangles and 2 pairs, nonetheless, to prove. And again, in terms of how you know to do this, right? You probably would not know to draw the altitude. So if I was going to do this for you, I would have the altitudes already drawn for you. Okay. But again, to know to use the small right triangles, and then use to prove the big ones are congruent. Again, it just takes more practice. Okay. But there we go. So we were able to prove that this roof is symmetric. So as I mentioned, this was an isosceles trapezoid. So there are a couple important ideas here. Okay. The first important idea is about the base angles, right? Now, because it's a trapezoid, it has 2 bases. And in this theorem, it says if you're an isosceles trapezoid, then each pair of base angles is congruent. So again, notice here you have the congruent sides, A, B, and C, D. So in this picture, the bases are here, base 1 and base 2. So that means that angle A and angle D are congruent. That's this top pair. You can just call them angle A and angle D. And then the top, I'm sorry, that's the bottom pair. And then the top pair, angle B and angle C, are congruent. And again, you can just call them angle B and angle C. So notice here, you have a 120, 120, a 60, and 60. If I go ahead and go to Savas and let us change it a little bit, you can see that as long as those sides stay the same, which they're going to, right? As long as these stay the same, right? Notice the congruence. Notice your base angles stay congruent, right? So they're all the way down there, all the way down there, right? You can make it as small or as big as you want to, but that remains isosceles, and the sides, or the angles on the bases, are congruent. Okay, second property of isosceles triangles involves the diagonals, right? So in this picture here, the diagonals of an isosceles triangle are congruent, right? So here, if I know that the sides are congruent here in isosceles trapezoid, then you have AC and BD are the diagonals. They're going to be congruent. All right, so let's take a look at here. We can move around the vertices as well of this isosceles trapezoid to see that the diagonals stay the same. And again, you notice as I move, right, they stay congruent. Move that one, right? And again, I think it has to do with this, it's the slant of the sides, these legs of the trapezoid, if you will, the fact they're congruent, the fact that the angles are congruent, right? So the distance from A to C and B to D is the same. Okay? All right, good deal. Okay, so let's go on to this next problem. Example. Actually, hold on. I'm going to stop this video and make a third video. Sorry about that, but it's a lot of stuff, and that first problem was was a long one. So I'm going to stop the video. Video 3 is coming up.